This tutorial we are going to solve a design problem on liquid adsorption, or sorry, on liquid phase adsorption. So I'm going to read the problem one time. So what we did is, like, we already performed some adsorption equilibrium experiments. So the goal is to recover an organic acid from fermentation broth at 25 degrees centigrade. So this organic acid can be any solvent which is normally used in downstream processes, like probably for purification of a pharmaceutical product, or maybe separation of some pharmaceutical product from a mixture, and so on. So at the moment we don't have to worry about what's this organic acid. Just assume we used a fermentation technique to produce this organic acid, and now we have to remove this organic acid from the fermentation broth using adsorption technique. And we are going to perform these experiments at 25 degrees centigrade. So which means we are going to maintain 25 degrees centigrade, and we are going to use some adsorbent, and we will selectively remove this organic acid from the fermentation broth. So assume we already performed the experiments in the lab to obtain the adsorption equilibrium data. You already know how to get this data from the lectures. So, and also assume we performed this in a very small volume of a reactor. It's a lab scale reactor, and we used only 25 milliliters. And in all the experiments, we added the same amount of adsorbent mass, which is around 0.5 grams. So which means the adsorbent mass in each experiment is something like a 0.5 grams per 25 milliliters of solution. So the experimentally determined equilibrium concentration as a function of initial concentration is given in table 1. So what I show here is, like, we have initial concentration, so C0 expressed in grams per liter, and then we have the equilibrium concentration expressed again in grams per liter. And just keep an eye on the temperature is 25 degrees centigrade, and then the reactor volume is 25 milliliter. So these are the things you should. So volume is 25 milliliter. Adsorbent mass M is 0.5 grams, and then we have our initial concentration here, and then this is experimentally determined value, CE, equilibrium concentration. So we have A, B, C, D, and E. We have to answer all. So you can expect this type of problem in the final exam. Probably if I ask this type of question, it will carry like roughly around 8 to 10 marks if you answer all A, B, C, D, and E. So first thing you have to calculate is the maximum adsorption capacity of the adsorbent used. So for this you can use the Langmuir isotherm, and then you have to draw the operating line on the adsorption isotherm plot. So based on whatever the data I gave you, you have to generate an operating line on the adsorption isotherm plot. And then the third question is like, okay, in the question I clearly stated we performed some experiments using volume like 25 milliliters of reactor volume and the mass of 0.5 grams of your adsorbent. So if you perform the same experiment, but this time we start from an initial concentration of say 15 grams per liter, and you perform one more experiment at starting from an initial concentration of 35 grams per liter. So let's put experiments from a solution of initial concentration of 15 grams per liter and 35 grams per liter. So if you go back to this table, so if you start from an initial concentration of 15, so what will be the equilibrium concentration, C here, and then you have to calculate this value using the graphical method. And then second one is 30, 35. So if you started the same experiments from a solution of initial concentration 35 grams per liter, what will be the expected equilibrium concentration? So what will be the CE value here? So you have to calculate this using a graphical method. So that's what we are going to do now. And then what will be the expected equilibrium concentration if we perform an adsorption equilibrium experiment starting from an initial concentration of C0 this time. So this time we will start from C0 of 40 grams per liter, but if you look at here, the volume is different. So instead of 25 ml, this time we use a volume of 50 ml. So we are performing an experiment. And the reactor volume is 50 milliliter, and let's maintain the same mass of 0.5 grams. So the reactor volume is this time is 50 milliliter, and then you have to calculate what will be the corresponding CE value. And then finally, calculate the amount adsorbed for the following experimental conditions. What's that? So let's say we started from an initial concentration of 50 grams per liter, reactor volume is 50 milliliters, and say the mass is again 0.5 grams. So what will be the amount adsorbed? So QE. So that's when we have to calculate C0 minus CE multiplied by V by M. So we have to calculate CE, and once we have CE, we can calculate QE. So let's solve this problem. So I'm going to solve part A. So how to get the maximum adsorption capacity. So we all know the Langmuir isotherm constant. Sorry, Langmuir expression is like CE by QE is equal to 1 divided by QM KL plus CE divided by QM. So this is the linearest version of the Langmuir expression. We are going to plot CE divided by QE versus CE. We will get something like this. So you have to draw the best fit line, and from the slope will be equal to 1 by QM according to this expression, and then your intercept will be equal to 1 divided by QM KL. So we know what is QM. 1 by QM is nothing but slope divided by KL. So therefore KL will be equal to slope by intercept. So that's the method. So I'm going to show directly on the Excel sheet how to solve this problem one by one. So let's do it. So I'm going to open the Excel sheet. We already have the value here. So I already copy pasted our initial concentration here, and then the equilibrium concentration here. So all we need to use is this formula QE. QE is I already showed you how to get this one. So QE is let's write here. QE is C0 minus CE multiplied by V divided by M. So that's what I did. So I can delete it. QE is equal to C0 minus CE multiplied by volume is here 0.025. You have to put this dollar symbol, which means so once you drag and drop, so everywhere it will be equal to the same volume. So I will show this how to divided by mass. So if you double click, if you see here, if you have that dollar symbol, so it will multiply by same volume throughout in each cell under in that column. That's what I mean. So this is your QE value. QE is C0 minus Ce multiplied by ratio of volume divided by mass of your adsorbent. So concentration is expressed in grams per liter, and your weight of your mass is expressed in grams. So the units will be grams per gram, not milligrams per gram. So this is fine. This is our QE value. So what we need to do is we have to calculate CE by QE. I'll go through this bit faster. So CE divided by QE, it's already here. So all you need is to plot CE versus CE by QE. So let's plot it. So just add a trend line, display equation, square value 0.991. That means it's a very good fit. So we have a slope and intercept. In the exam, you have to write clearly on the graph sheet. So in the x-axis we have CE, in the y-axis we have CE by QE, and so on. And you also have to write what is your slope, what's your intercept, something like can quickly paste it on the PowerPoint. So in the exam you must clearly write it on the axis, each and everything, like CE expressed in terms of grams per liter. You have to write units, if not I will not give marks. QE grams per gram, and then you have to write your best fit equation, and then you have to tell what is your slope, what's your intercept, and you have to clearly state how you calculated KL, how you calculated QM. QM is nothing but your adsorption capacity. And if you remember, I said to you in the lectures, if QE is expressed in terms of grams per grams, the unit of QM will be grams per gram. And if CE is expressed in terms of grams per liter, KL will be expressed in terms of liters per gram, the inverse of the concentration units. So keep this in the mind. So slope value here is 3.5171 and intercept value is 8.1. So our QM, the maximum adsorption capacity, that's what I asked in the question. QM will be equal to 1 divided by slope. So it will be equal to 0.2383 grams per gram. And if I ask you to calculate binding affinity, you have to calculate binding affinity. I think it will be equal to slope by intercept, 0.4321. Yeah, so I think this is enough for the moment. So this is we already answered the part A. So the maximum adsorption capacity is 0.28433 grams per gram according to Langmuir isotherm constant. So that's your part A. So the maximum adsorption capacity of the adsorbent is 0.2833 grams per gram. And then now you have to draw the operating line on the adsorption isotherm plot. So how to draw that line? So we know that, let's go back here. So I hope you all remember what I said in the lecture. So we have CE, we have QE. If you plot, you will get something like that. So we have the volume, we have the mass. So take this ratio, negative of volume to mass ratio. So, and then you have to generate a line whose slope should be equal to minus V by M. So you can draw this line starting from any point on the x-axis, from this point, or it can be from this point, or it can be from here. So this can be 10 grams per liter, this point can be 40 grams per liter, this point can be 50 grams per liter. So you can select any point on this graph, but you have to draw a line. That line is called operating line, and the slope should be equal to minus v by m. So that's what we are going to do using Excel. So if you want, you can use the calculator, or if you want, you can use Excel sheet. It's up to you, whichever is comfortable for you. So let's calculate it. So if you remember, so I will keep this plot aside and let's plot CE versus QE. So this is a plot of CE versus QE. So on the x-axis we have CE, in the y-axis we have QE, and don't forget the unit. CE is expressed in terms of grams per liter, QE is expressed in terms of grams per gram, and then we can calculate the slope of the operating line. That should be equal to minus of V by M. So V is 0. Okay, yeah, and always careful with the unit. So I converted the milliliters into liters. So 25 milliliter is equal to 0.025 liters, and mass is expressed in terms of grams. So if you take the ratio V by minus V by M, so minus 0.025 divided by 0.5, and the unit will be liters per gram. So minus liters per gram. I'm going to say going to keep the line for this line can serve like a guideline. So what we need to do is, like, we have to draw some operating line. On that operating line, the slope should be equal to minus 0.05, which is here, minus 0.05. So how to do that? So let's assume we can draw the slope starting from, say, 0.30 on the x-axis. So how to do that? So let's take 25, 26, 27, 28, 29, 30. So take some number which is slightly above 30 grams per liter. So 30, 29, 28, 27, 26, and 25. This is some cheap trick, but it will work. But it's easy to implement, especially if you have access to Microsoft Excel or any other spreadsheet. So let's call this as C for the moment, and then we know the slope value minus V by M. So this value is equal to minus 0.05. So just multiply C multiplied by minus V by M ratio. You have to listen to the lectures if you have no clue what's going on now. So just multiply it, these two values. And then I said we are going to draw some operating line starting from 0.30. It should hit in your equilibrium curve, and this line should be equal to minus V by M. So that's the part B of your question. Draw this operating line with correct slope value that should match with your experimental condition. So our experimental condition states 0.025 liters and 0.5 grams. So this slope should be equal to minus of this ratio of volume to mass. Yeah? So at 30 we have minus 1.5. So we have to make this value 0 at 30. So that will give something like 30, 0. So your y value will be 0, x value will be 30, and that will be exactly at this particular point. So let's do that, plus 1.5, and then we do for the rest of the column. So this value plus 1.5, concentration here plus 1.5, minus 1.325 plus 1.5, that's 0.15, and so on. So all we need to do is now we have to plot, select data, add x value, start from here versus this value. So whatever this line you get, that's nothing but your operating line. You can give the name, say operating line, minus V by M that's equal to minus 0.05. So this is your correct operating line. So I think we answered part B. And then let's copy paste this one into PowerPoint here. So I hope you all can follow up to this point. So this is our operating line, the one in the orange one. So what's the part C? So what will be the expected equilibrium concentration if we started this experiment from a solution of initial concentration 15 grams per liter and 35 grams per liter. So what I asked is like if we started the oh my god, where is that PowerPoint? So if you start the experiment from 15 grams per liter or somewhere here 35 grams per liter, what will be the corresponding equilibrium concentration? This one is really simple to do. If you want, you can use what do you call? Is it like they call it as a set square, or if you want, you can use two different scales. So I will use some. I don't know how to use it on a PowerPoint. Okay, I can generate some two rectangles maybe. Just assume these are like two scales we have. So all we need to do is like you have to put the scale parallel to your operating line. Something like here, I think it's not parallel. So still it's not good. You can use a set square. So you can buy a geometry box, and in the exam if I ask this question, I expect you to use both graph sheet and Excel sheet. Sorry, normal graph paper and Excel both. So what you need to do at the moment is, okay, let me change this color.
Thanks for asking. I'm good. Just keep on talking to me.
That's my Alexa. I don't know why it's talking. Okay. So what you have to do is like, so we already have the operating line, and if you go back to the question here, I asked what will be the concentration if you start from 15 grams per liter. If you perform the same experiment starting from a solution of 15 grams per liter, so what will be the expected equilibrium concentration? So I already explained this in the lecture videos. So if you go back here, so what is this orange line exactly states? It's like 30, and then you have here your equilibrium concentration here. So if you start from 30, and if you draw the operating line whose slope is equal to minus v by m, it will cut your equilibrium curve exactly on Cu value. Yeah. So if you see here the blue point, that's our Cu corresponding Cu value if you started our experiment at 30 grams per liter. Yeah. So I showed this using Excel sheet. Like we used some tricks. We used some trick from 30 to, where is that? We started from 25, 26, 27, 20, 29, 30, and we used some tricks to get some value that allows you to plot this line. Yeah. So, but for this experiment, it's very simple. We already know the volume, we already know the mass, and we know the initial concentration, and we know the equilibrium concentration. So if I ask you just to draw that operating line, all you need to do is take a pen and just connect it. You see here 20 is, if you start your experiment at 20 grams per liter, your corresponding equilibrium concentration is 15.3. So it's somewhere around here. So all these are operating lines. So all these are operating lines. And then yeah, and so what it states is like, so the line that connects your initial concentration with your equilibrium concentration here, that should have a slope of minus v by m, and if you perform the experiment all with same volume to mass ratio, then this line will be parallel to each other. You see here, they are all are in parallel to each other. So these lines. So if you start from 10, your equilibrium concentration will be here. If you start somewhere in the middle, say like 8 grams per liter, which is around here, just look at the cursor. Your corresponding equilibrium concentration will be somewhere around here. So if you go to part B of your question, if you start from 15 grams per liter, what will be the corresponding equilibrium concentration? If you start from 35 grams per liter, what will be the corresponding equilibrium concentration? So all you need is to take a scale, and then just then you can put one more scale in the bottom somewhere like here. Oops. So something like here, and then all you need is to move the line. So what's the question I asked? So what will be the concentration at 35? Okay, and another one is 15. So just go, where is your 35, which is here. So draw a line connecting these two. And then another one is 15. Draw another line, say starting from 15 to, just to follow the scale. So from here, from the graph, you can interpret what will be the corresponding equilibrium concentration. So it cuts somewhere around here. If you draw a line starting from here to down, so it will cut your x-axis somewhere around so 10, 11, 12, 13. It will be somewhere around 10.8, something like that. So you have to use the graph sheet and you have to get the correct value, correct CE value, and do the same process again here. You come back here. Let me change it to just to follow the red color arrow. So if you start your experiment at 35 grams per liter, then you will reach an equilibrium. The final equilibrium concentration will be equal to roughly 30.8 grams per liter, somewhere around this line. So that's how you have to calculate. And if I already gave you volume to mass ratio and also the C0 and CE value, then you don't even have to do this type of calculations like 25, 26, 27. All you need to do is just to connect your initial concentration point 20 with your C0 point, which is in this case around 15.3 grams per liter. So this is your operating line, and then we already calculated what's the CE value. If you perform the experiment starting from 15 grams per liter, it will be somewhere around here. And then if you perform the experiment starting from 35 grams per liter, you have to use the scale and calculate the correct CE value. So that's the part B. So if you start from 35, the value will be roughly around 30.8, I guess. Do it yourself and check the values. And then if you start the experiment starting from an initial concentration of 15 grams per liter, your CE value will be somewhere around 10.8 or 10.9, near to 11 grams per liter. Yeah? So try to check it. You have to buy a graph paper, plot these values, and then draw the operating line, and then use the scale, draw some parallel lines, some lines which are in parallel to your operating line, and from that you can calculate your CE value. If you want to calculate, say for example, somewhere around here, say like 6 grams per liter. So you will have your equilibrium concentration somewhere around say like 1, 2, 3, 4, something around 3, in between 3 to 4 grams per liter. So that's how we have to calculate. So if we start an experiment say from 41 grams per liter, for example here, your equilibrium concentration will be roughly 36 grams per liter. Yeah? So you 41 grams per liter, which is here, and then you draw the operating line, and then wherever the operating line cuts your equilibrium data, draw an arrow down to check where it hits at in the x-axis. So this value will be equal to your equilibrium concentration. And if you want to calculate what will be the amount adsorbed at that particular, if you start, say for example, if you start the experiment at 15 grams per liter, let me change this color to green. So let's say we started the experiment at 15 grams per liter. So our CE value will be roughly equal to 10.8 grams per liter. If you want, we can also calculate the QE value. All you need is to check wherever the operating line intersects your equilibrium curve. So just locate that particular point, and the corresponding value in the y-axis, that should be the amount adsorbed. So that will be roughly around 0.218 or 0.21 grams per gram. Yeah. So you have to use the graph sheet and try to do it yourself. All I'm showing here is how to use the equilibrium data and how to apply this graphical method in order to solve the problem. So I think we answered both C, A, B, C, and now we can go to D. What will be the expected equilibrium concentration if we perform an adsorption equilibrium experiment, starting from an initial concentration, say 40 grams per liter, and then volume of 50 milliliters and mass of 0.5 grams. So we have this adsorption equilibrium data, but from this we have to calculate if we start from a different volume. Yeah, say let's go back to this one. So now what I asked is like I changed the volume. Volume is equal to 50 liters. That should be equal to 0.05 milliliter. And then mass is again same. Mass is nothing but 0.5 grams. So in this case, we put it down. So in this case, the slope minus V by M, that should be equal to minus 0.05 divided by 0.5. So our new slope value, this is the slope of the operating line, minus 0.1. So what we have to do now is like, let me remove these ones. So we have to draw some operating line. I said we started the experiment from 40 grams per liter. So we have to draw some operating line, and this time the slope should be equal to minus 0.1 instead of minus 0.05. So we have to calculate we have to draw the line starting from this point, 40 grams per liter, and the slope should be equal to minus 0.1. The procedure is same. Yeah? So let's type C. This time I'm going to say 35, 36, up to 40. And just going to repeat the process. So this time your slope value is minus 0.1. Sorry. So you just multiply this value. And then we have to make this value minus 4 to 0. That corresponds to your 40, concentration of 40. So how to do that? Just add +4, that will make this value 0. Just drag and drop throughout the column. So all we need is to plot this in the x-axis and this one in the y-axis. So let's plot. Select data, add x, and y value is this. Press OK. So if you look at this gray line, so this is the new operating line. So if you started the experiments with a solution of an initial concentration of 40 grams per liter, and if you added 0.5 grams, and if the reactor volume is 50 milli, this is liters, 0.05 liters. So then your corresponding equilibrium concentration will be somewhere around here. So let me copy paste this value, this graph in the PowerPoint. Sorry for going a bit slow, but this is a design calculations. It will take some time to learn, but it's worth to learn these things. So this is your new operating line, and the slope of this line is equal to minus 0.1. So the slope of this line should be equal to minus V by m should be equal to minus 0.1, and this slope value minus V by m is equal to minus 0.05. So this is our initial concentration C0, and if this is our operating line, so this operating line will hit or intersect with your equilibrium line, which is shown in blue, exactly at CE. So the corresponding value, this should be equal to CE, and the corresponding Y value, that should be equal to QE. So our CE value will be roughly around 35, 36, 37, 38, 39. C will be roughly around 38 grams per liter, and QE value will be roughly equal to 0.2122, something around 0.223, something like that, grams per gram. So take a graph sheet and calculate these values. So this is your operating line, and this is another operating line. Operating line, if you started the experiment with a volume of volume of 25 milliliter, and this one is 15 milliliter, and the mass is 0.5 grams, and here the mass is 0.5 grams. So I hope you all can follow until this point. I think we solved up to part D, I think, part D of the problem, yes. And then the final question is calculate the amount adsorbed for the following experimental conditions. So let's assume we started the experiment with 50 milligrams per liter. This is the initial concentration of our solution, and then volume is 50 milliliter, and mass is 0.5 grams. This one is very simple to calculate. Yeah? Either you can use the graphical method, or you can even use the formula. Yeah. So let's say if you go back to here. So if you see the volume in part D, the volume is 50 milliliter and mass is 0.5 grams. So the slope is same. So all we need to do is you go back here. So let me copy paste these two. So all we need is to use the two rulers, or you can use a set square, and then use this one, another ruler. So just move the graph, your scale, until you reach 50, and then draw a line starting from 50. So you have to draw a curve like that, and then whatever the corresponding point which cuts at the equilibrium line, you just calculate the corresponding x value. So if you started the experiment with 50 grams per liter, your and volume of 50 milliliter and mass of 0.5 gram, you at the end of your experiment or at equilibrium, the concentration of your solution will be equal to this value, which is 46, 47, somewhere between 47 to 48, roughly 47.5 grams per liter. And then the corresponding amount adsorbed, you can draw a line here. It will be roughly around 0.29 grams per liter, or you can use the formula C0 minus CE multiplied by V by M. We know C0 is 50 minus CE is just now we interpreted from the from the graph 47.5 divided by multiplied by volume is volume is 0.0. Volume is what? I think I did a mistake in the beginning of the solution. If you go back to Excel sheet, no, correct. Yeah, I already converted into liters. Yes, let's go back here. I think it's correct. I didn't do any mistake. So this value is correct, yeah. So this is in grams per gram. So how to multiply? So this is multiplied by volume is 0.05 liter. 0.05 divided by mass 0.5. That value will be equal to somewhere around here in this graph. So I think we solved this problem. You will expect this type of problem in your final exam. So don't take it lightly. Yeah? So try to buy the graph sheet, plot it on the graph paper, and then try to get the data. Yeah? In the exam, you are not going to get the same type of question. Yeah? Probably I will. If you go back to this problem, I will ask you to assume some volume. I won't, instead of giving the volume 25 milliliter, mass is 0.5 gram. I will just tell like assume a suitable volume of within the range like 25 to 50 milliliter. So you can assume or maybe 29 to 27 to 29 milliliter. So then you have to assume some volume, and then I will ask you to assume mass in the range of say like 0.1 gram to 0.9 grams. Yeah? So then you have to do the calculations. You have to fix some volume by yourself, you have to fix some mass by yourself, and then solve this type of problem. Yeah? It's like for example, say like so let me go back here. Say for example, I might ask like assume any values for volume in between 25 ml to say 80 ml, or maybe 60 ml to 80 ml. Then you have to select some value. Let's assume V is equal to what? Some maybe 68 milliliters. And then I will ask you to assume mass is equal to, assume any values in between 0.6 to 0.8 grams. You can assume say 0.65 grams. So then you will have C0, you will have CE. So from that you have to calculate. Say like if C0 is 100, CE is 50, and then you have to calculate QE value, 100 minus 50 multiplied by 0.68, so 0.68 liters divided by mass is 0.65 grams. So from this you will get your QE value. Just pay attention how to convert milliliters to liter. Don't do any mistake. Even if I did some mistake, you don't do that. Yeah, just you should know how to convert milliliters to liters or liters back to milliliters. So try to pay attention to these details, and then once you have C0 and QE, you can draw QE versus CE, and then you know what is your C0. Say this point is 100, say this point is 50. So just draw the line. That line will be equal to minus of your 60, minus of 0.68 divided by 0.65. So I hope you all can follow this. Yeah. So I'm not going to upload the notes for this lecture. You have to listen to this lecture and take the notes by yourself, because practically I solved the problem using Excel sheet. So I cannot type it on the PowerPoint, like where to draw the line, how to draw the line. So just listen to the lecture, practice this problem. This is a very important problem and is really widely used technique in industries. Yeah, in the exams you might even expect like a heavy, like some big numbers. So I will give you some equilibrium data, and then I will tell, say, volume. This time we are going to deal, say, like 2000 liters, for example, and the mass, say, 1000 grams. Just to take the ratio minus V by M, that should be equal to 2000 divided by 1000. So minus V by M should be equal to 2 minus 2. So how the slope will look like for this type of problem, we can give a try using the same data. Say like I'm going to put minus 2 here. I don't think it's a good idea. Okay, let's plot it on this graph. Select data. It's very high. Maybe I can put 29.9, 29.8, 29.7. Yeah, and then we can remove these two values. So this is our slope value of minus 2 by m. Okay, which means we added a mass in excess. So this is not a good value. So anyway, I will check these values. Anyway, I will solve the problem myself before giving you the problem in the final exam. So I will give the correct experimental conditions that will allow you to create a correct slope, and then from that you can get your initial concentration. Yeah? So from that you can get your equilibrium concentration. So I'm going to stop recording this video, and then try to watch this video, try to practice this problem. Yeah, so you will have this type of problem, and you have only 3 hours to write your final exam. So unless if you are not practicing this in the home, it will be very tough. And for the exam you must use graph paper for this type of problems, because only then I will know you you didn't copy or something, yeah, because it's very easy to share the Excel sheets through email from one person to another person, and so I prefer you to use graph sheets individually so that I can know each of you worked on this problem. So thanks for listening.